This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 48. A look at Ansys' ever-growing tools for additive manufacturing, available in Ansys 2019 R3, along with news and events. Welcome to another episode of our podcast. I'm Eric Miller, one of the owners here at PADT. It is the end of a long week here in Phoenix as we celebrated AZ Bio Week with lots of talks and panels and award ceremony. And it's a lot of fun when we get together with people in the medical device design and manufacturing community here in the Valley and in Tucson. And good to see some of you who might be listening to this podcast at various events this week. It was a lot of fun. One of these years, I'm going to plan ahead so I have time to offer a seminar on simulation for device design. We certainly use it with our customers to design medical devices, and I think it'd be a great topic. We're doing more and more stuff in that area with Ansys, so more and more capability from the Ansys side of things, including, hopefully we'll have a podcast soon about this, the fact that you can now get to a FDA certification with the help of simulation. But more on that later, maybe next year. We're starting the fourth quarter, and I'm happy to say that Q3 at PADT, we added some fantastic companies as new Ansys users in our family of Ansys users. It may have been a record for new accounts. I'm not quite sure. We don't keep count and how you count, whether it's seat count or number of customers. I don't know, but it was a lot, and it was close to maybe a record if it wasn't a record. Privacy rules being what they are, I'm not able to even mention their names, but I can say welcome if you're listening, and we look forward to working with you in the future and in many, many years to come and help you use Ansys to get your products to market better, faster, smarter, cheaper, etc. The podcast itself is doing well. This is episode number 48, so we'll be doing our kind of an important 50th episode very soon. And we'll also soon have 15,000 downloads, which is great. We're honored to have so many listeners. In fact, one came up to me to say hi. A group of us were talking at the Colorado Additive Manufacturing Day last week. And I got to apologize. I was so shocked that somebody actually listened to the podcast and stopped by to say hello that I didn't respond like I wanted to and thank them and get their name. But I'm so glad you stopped by and let us know that you listen. It's good to know that it's not just ending up in the unlistened to pile on your iPhone. So glad you enjoy the podcast, and please do not hesitate, everybody else, to step up and say hi when you see us, and remember to spread the word. Let's get on to the interview for this episode. We're going to take another look at the capabilities available at Ansys 2019 R3. This is going to be about additive manufacturing and topological optimization. As you'll learn when I talk with Doug Oatis, who's in our Denver office, that there's a lot in there. We just had a discussion about this on R2 not that long ago, and there's enough in R3 to talk about. So let's see what's been added. Welcome. I'm on the Microsoft Teams with Doug Oatis in our Colorado office. And the first question I have for you, Doug, is why didn't we record this when I was 5 feet away from your desk last week?
I think you were in 12 meetings at the same time. And so that was probably why.
I didn't dawn on me that we should have done it when I was there. And we had a great discussion with one of the people in Ansys that's in charge of development for or one of the people in charge of development for the additive product suite. So we had a lot of good discussions with him while we were there, that some of which will help us answer some of the questions we're going to talk about today.
Yep.
But let's go ahead and get started on that. So like I said, I'm with Doug Oatis, who's up in our Colorado office, and I'm here in our Tempe office, and we're talking about additive at Ansys 2019 R3. And we checked. Yes, we did just have this discussion in July for R2. And it's coming. I guess the point, Doug, is that it's coming fast and furious. There's enough to talk about between these point releases.
Yeah. It's It does feel repetitive, but it's just the topic, not the content of it. Mm-hmm. And so it's always there's always a few kind of big hitters of what's an actually new feature versus what are tweaks more of kind of productivity or general use enhancements.
We're not adding a new turbulence model buried deep down inside of the solver. This is major. There are major efforts to add capabilities in this area,
right?
Which is good. So let's start off with the kind of the obvious one: is what's the most important thing that you think came out in R3?
It's kind of a two-parter to me, and so one is the level set topology method for topology optimization. I don't know if I repeated myself on that. And I think I claimed ignorance on the specific numerics behind what a level set is. And I'll use the same excuse. I can understand it for about 20 minutes and then I'll have lunch and I'll forget everything about it. And so it was a beta feature back in R2, I believe. And it's released now. And really, I really like it because it creates a super clean STL file. Like
much better.
So the SIMP method or the density based method, every time I run it, I almost always like assume that I have to run some type of shrink wrap or something like that on it to clean it up to get it to be something usable from a printing standpoint or a downstream simulation. But the level set is just, it's so clean. Like every time I run it, I don't know. As much as you can be amazed at, simulation tools. Maybe I'm just old and disgruntled now, but it does a really good job. And so it's been there in the code for a bit, but really, the downside of being kind of the newly non-beta or newly released is it just doesn't support everything that the SIMP does, and so most of those are going to be kind of the manufacturing constraints. And really, it's really just a matter of time before those get put in there or get enabled. But kind of the cool thing, and one of the customers that we've run into, one of our customers, one of the things that this level set does is some of the criteria, in addition to just being mass or volume based, does center of gravity or moments of inertia. And so kind of the ability to run a topology optimization and have a kind of dynamic equivalency is kind of a really nice feature. So that's kind of the first thing that's not necessarily new, but more released and just something that you should be checking out. And then within the additive prep, we have so many very similar sounding products. So additive prep, that is the tool within SpaceClaim that is a rules-based utility that kind of helps you determine what orientation and you should pick based off of the supports you'll need, the distortion you could expect, and the build time. And so in addition to being able to do all of that, it now actually has the ability to generate a build file. And so kind of you can use that utility to figure out how I want to actually place and orient my part. And then you can go through and there's all these additional machine build parameters. So you can do some remelt passes and stuff like that. And I'm going to butcher the names of those because I'm not looking at the sheet right now. But basically, so you can orient it properly, kind of expect what kind of distortions you'll try to minimize that. You can build your own support structure using some automated tools within additive prep, and then generate your build file and go from there. And so it's kind of a one-stop shop.
And this is all, it's not solving like an FEA model in the back.
No, it's
all like closed form solution.
Yeah. It's I don't even know if it's kind of closed form solutions or just rules of thumb that have been codified in numerics. And so, it's not like you have to rotate your part and wait for it to solve. It just is, I don't want to call it Discovery Live-ish, but it's kind of I don't even want to call it a solve. It's just here's what you could expect.
Yes,
and so, I mean, obviously you could take all of that and then run it through, additive print or workbench additive to actually capture distortion effects.
Right. And compensate for them. Yeah.
Correct.
Yeah. So this is in the Space Claim interface, correct?
Correct.
And it's a nice tool. I think people are kind of got in their head. I know that I struggle with it, that there's these solvers that look at a layer by layer simulation of a build or multi-layer at a time build, which are there. That's additive print and additive science, right? And then there's this additive prep, which does these kind of real-time calculates things as you make changes.
Right. So additive print is more. Maybe we'll just boil it down to like fancy vector math, where it's just looking at kind of overhangs and orientations and stuff like that, versus a build direction and kind of doing some hand waving off of that.
Okay.
And so again, it's rules of thumb where if you wanted to do a layer by layer, you could pass that over and use the workbench additive tool, which runs a coupled thermal structural simulation, and you solve it all with a mechanical. Or the other way you can do it is you can solve it within additive print. And so there is some overlap between the two. One is mechanical solving thermal and structural. You have the ability to add whatever kind of material properties you want that mechanical supports. On the additive print side, that's more of a thermodynamics, and it can there's a couple of different solve levels there. And so you have like a kind of a basic level, which is kind of an equivalent to what workbench additive is doing in mechanical. I'll probably get dinged on that from Ansys because it's close but not exactly. You can make it a 1-to-1 using some command snippets in mechanical. But then the other thing you can start to do is actually solve for distortion, stresses, and strains using actual scan data. And so there's kind of two levels on that. And so you can basically take into account the scan direction and kind of get this anisotropic stress and strain field that develops due to the direction that you're actually building it. Or you can actually solve, a very detailed using actual scan data, and capture stresses and strains, on a layer by layer basis. And again, the reason why you would do one versus the other is the classic FEA debate of how long do I want to wait for an answer? How important are the details to me? If I'm not setting these machine parameters and I'm just trying to figure out, can this survive the build cycle? You have a couple different flavors you can choose from depending on the material properties you're trying to use.
That's pretty cool. Okay. I did not. So it's come a long way in capability and a lot of different levels of capability.
Yeah. And there's a lot of tools that do a lot of different things, and the Venn diagram is kind of noisy in the middle. Depending, and again, it really depends on how you're approaching additive. And so you have people that have machines in house, and the nice thing is you can there's calibration steps that you can go through on the Ansys additive product side. So that's additive print, additive science. Whereas if you don't have a machine in house and you don't really necessarily care about machine specific parameters, where you're assuming that the machine has it has a full remelt on each cycle. You're not introducing any type of defects or anything like that. You're just concerned about a layer by layer build up and what happens when I remove my supports. Do I need to do a heat treat cycle after that? Then you could solve that with a mechanical. And so it kind of depends on the organization, what you have control over, what you're comfortable with. So if I don't want to do any FEA, like I don't care about meshing, then additive print is a really nice tool, because you essentially specify a voxel size, which is their kind of underlying numerics of everything, rather than meshing it with either a layered TET or a Cartesian mesh within mechanical. And so if you don't care about meshing, you just want to basically specify a size that, rules of thumb, trying to capture a certain level of detail, then additive print's great. You just throw it in there, run. You can do some distortion calculations off of that. And there's a lot of additional tools now that handle either custom supports or support groups or volumeless supports, depending on how detailed your I think I heard someone call it like tribal knowledge on,
yes.
I know how to support my parts, and this is how we're going to support it, and we'll deal with the machining aspects of it later, or the cleanup. So yeah, I mean, there's a lot of tools. Each one kind of serves its own unique role, but there is some overlap, and there's some definite, one feeds into the other kind of.
That's good.
Aspect.
So that is one thing that's changed. I don't remember which release, but you can now import your own supports, I think.
Yeah. You've been able to do that since R2. Oh man, I think R2.
Okay.
Now I'm debating whether it's R1, just because it's so
beta. Yeah.
yeah. It's always that's the. I was on a phone call earlier today, and I was blaming Microsoft for something, because that's the easy thing to do. And so you can always claim something was beta when you don't remember.
Right. Exactly.
So yeah, I mean, you could import your own supports, and just now you can essentially group those together and have kind of a mixture of volumeless and solid support types with an additive. And both products, on the Ansys additive, that's the voxel based method, right, versus Workbench additive, which is mechanical meshing and material properties using the APDL solver. Right. Both of those have different ways of importing supports and discretizing and applying the correct knockdown factors for your support, for how the support is numerically modeled.
Right. Because they're very thin. It's one of the things we've struggled with is they're paper thin sometimes, and so you got to process.
Yeah. So it's kind of because they're not just there. Support isn't always there as like to support something. It's there as a additional conduction path.
Right.
And so trying to. Yeah, it's an interesting world of additive.
Yeah, we had an interesting discussion about the analyst trying to understand additive, and the additive manufacturing engineer trying to understand simulation. That was one of the discussions we had with the Ansys development person, was making sure that we have tools that meet both needs, because we get in there as very experienced simulation people and don't quite know what they're talking about. It's because these are machine parameters and melt pools and things like that.
Right.
Whereas the manufacturing guy's going, what's a mesh? So.
Yeah. I mean, it's kind of the classic case of, the numerical ability is there now.
Yes.
And so it's hard convincing an industry that isn't used to that to stop wasting money and
yes,
breaking stuff, or discarding a whole bunch of parts, and to take a different way, a different look at it.
Yes.
And so, yeah, at lunch when we were talking this, we had a high frequency electromagnetics guy at the table, and he was kind of chiming in of like, well, that's how, high frequency electromagnetics was for, the past, maybe 15 years ago. People would be like, yeah, you could probably do some academic stuff with it, but now like the ability's there. So might as well use it.
You would never design an antenna now, a high frequency antenna now, without using simulation. That's probably, most of our listeners are probably simulation people. So when working with your company on additive, one of the things you may be facing is just convincing the manufacturing team that simulation is a good answer. And the tool is definitely coming along. I think all these things you've talked about have really been a direct result of people like us using it on real parts and going, hey, I need to know this, and hey, I need to know that, and can you add this capability? So yeah, it's been really good. Yeah. What else did you see in there?
Yeah, I mean, one other thing I forgot, I'm going to pivot back to topology optimization.
Yes.
Is so on the density based side.
Yes.
So you can either do this numerical black magic of level set, which I won't try to describe, or a semi kind of density based. And you can kind of start to build your own criteria. So you can kind of say, we can, or I'm sorry, objectives. And so you can basically say, I want the displacement between these two surfaces. So I can tag a surface and say, I want you to pull a scalar value of displacement in the XYZ direction.
Okay.
And then same thing on another surface, and then build a composite. Basically, it's just kind of some additional, almost exposing the probe functionality as an objective within the density based. And so it's kind of a nice little tool. I've kind of played around with it a little bit. It's kind of reminds me of if anyone's ever used the a solution combination or load case combinations in APDL. It's kind of like that. But
that's a good way to look at it.
Yeah. So it's every time it's something new. Sometimes it's just kind of like that'd be cool versus an actual like new product like the additive prep build processor, or the level set being kind of fully exposed.
So you're going to be talking about this in a webinar on the 9th. Is that correct?
That's the rumor.
That's the rumor.
Yeah. So, we'll have pictures of everything and, kind of be able to dive a little bit deeper into seeing it. So,
yeah. And definitely a chance to ask questions and see it live.
Yep.
It's definitely, if you've been using a competitive tool, this is another thing I talked about with you and the Ansys folks, as well as a couple customers. We've had a lot of customers that have gone out and gotten competitive tools that are really design based, CAD based additive manufacturing tools, and especially on the topological optimization side, they've been somewhat limited. So if you haven't looked at Ansys, you're using one of those and finding it constraining, it's probably time to come back. We said this at R2, but even more so at R3, it's probably time to come back and take a look at level set, take a look at all you can do with the density-based topological, look at our pre-processing tools for additive, as well as our ability to simulate the additive manufacturing process itself. And then additive science is still coming along. We have a lot of high hopes for it, but that's predicting kind of the science of the metallurgical science in the process. There's a few things correct in this release, but nothing that we're like go out and use it everywhere yet, right?
Yeah, I mean, I think a lot of it is almost just understanding how it fits into the development cycle, and so trying to kind of wrap your head around, well, when do I run this? And I think one of the better explanations was you actually kind of run it before everything, so you kind of get an idea of what machine setting should I be using so that I don't screw everything else up. So I mean, like the grain structure prediction, stuff like that, obviously it's there's quite a bit of development in order to capture that and predict that on a material by material basis. And so, question's always going to be like, when is X material going to be there? And it's like, it's a work in progress. And so, certain materials are validated for use in different solvers, and it's just a matter of time kind of to build that up. And there's quite a lot of I was getting an explanation of what goes on behind the scenes, and there's quite a lot of material curves you need to provide in order to properly characterize. And it shouldn't be shocking. It's we're basically melting and re-solidifying a powder with a laser, and of course it's complicated. Like it's like this. There's a reason that it's hard. So
there's phase change, nonlinear materials. Time dependent.
It's the old like Louis C.K. bit about being mad at your cell phone. It's like, well, your phone's communicating with a satellite in space, which isn't technically right, but it's like, why don't you just it's magic. Like, it's magic. This is hard stuff. So it'll take a little it'll take a little bit of time and just to kind of, build those out and kind of better understand what's going on. But, it's every rev is, something new and cool there.
So definitely, if you're into the metallurgy side of things, check it out, the additive science, and see what's there and if it's useful to you or not. I'm very excited about when there's a lot of infrastructure that needs to be put in place, but when we can predict the behavior of these metals at that level, at a grain boundary level, at a grain size level. Wow, there's so many things we can do with that. It's going to be pretty powerful. So I'm excited about it.
I mean, if anything, just being able to kind of better predict a creep behavior of a heat treat off of a printed part without so many assumptions, that'll be a nice tool. And
I think that's where it's going to be really applicable is modeling, yes, the build itself, but really modeling that post-processing that we're doing, the hipping and the heat treat and stuff.
Yeah. So
good.
Excited.
Excellent. Anything else you want to add? Any words of wisdom for those getting into topological or additive simulation?
Not really. I mean, I think the topological has become user friendly enough that it feels like it's hard to break something.
Good.
So
that's good.
I mean, my personal experience as far as level set versus density based is the level set's a little bit slower.
Okay.
And so just don't be surprised at that, but it gives you kind of a cleaner result at the end. It's topology optimization. Just use it. It's come quite a way. It's it was kind of a limitation, and like 4 or 5 years ago, I don't know. I've been using it too long. But I remember it wasn't very good for a while, and now we don't really have a whole lot of problems with it.
Yeah.
And so with that space claim, the additive prep tool is the first time I opened it, I thought it was a lot more complicated than what it actually was.
Right.
And so I'm like 95% certain there's documentation in the space claim that kind of walks you through the general process, and it's a lot easier than you think. It at first pulls up and you feel like you're like navigating, like you're on a submarine navigating all these screens and you don't know what you're doing. And really you just look for green fields, click there, see what the orientation is, and you go on your way. That's all it is.
Nice.
And then as far as the multiple additive process simulation goes, it really, I almost want to say it depends on what you're comfortable with, what you're trying to simulate, and what you have control over. And so depending on those answers, I would steer you in one way or the other. But I mean, there's wizards that guide you through everything.
Good.
And then,
Good. They're definitely paying attention to workflow. That's definitely in discussions with them. It's been a key thing. Just don't just throw a bunch of features out there, but make it usable. So excellent. So I appreciate it, and we'll probably be talking about R1 before we know it.
Yeah, schedule in 2 months.
Exactly right. Which is fantastic. So 2020 R1 should be out beginning of 2020, and I'm sure they're putting a lot of effort into the additive and topological space. So we'll have plenty to talk about when they do that. So thanks for joining me, and we'll hopefully see you soon.
Sounds good.
Thanks, Doug.
Thanks.
So as you can tell by our talk, this area is growing fast, and we have to continue to discuss this probably every 3 or 4 months just to keep up with everything they're adding. And since PADT is that rare company that specializes in both simulation and 3D printing, this topic is really near and dear to us and very exciting to see all the things that are going on in the Ansys world. Let's go ahead and take a break and listen to a commercial.
On these podcasts, we have a lot of fun talking about, all things Ansys. From new features to reminiscing about the good old days of batch input files, only a few listens will convey the fact that we really are passionate about this set of software tools. Did you know that you can have that passion and experience at your service to help you purchase and use tools from Ansys? PADT is an Ansys Elite Channel partner, and if you live in the southwestern United States, you can purchase your licenses and get your support from the people on this podcast. As you can tell by listening, we not only know the tools, we know how they are applied by users in real-world situations to drive product development. Get more value from your Ansys investment by working with PADT to manage and enhance that investment. If you are located in Southern California, Arizona, Utah, Nevada, New Mexico, Colorado, or Texas, and you are interested in exploring Ansys as your simulation solution, adding to your existing Ansys products, or simply getting support from the experts who go the extra mile to make you productive, contact PADT at 480-813-4884 or send an email to sales@padtinc.com. We are here to make sure you get the most of your investment in the fantastic suite of tools from Ansys Inc. And don't worry, even though the email says sales@padtinc.com, our sales experience is just like the podcast, knowledgeable and interactive with some fun sprinkled in. Give us a call or send us an email. And thank you for listening to our little commercials. Now, back to our podcast.
I have to apologize looking at the what should be silence in between the various cuts on this recording. My air conditioner is on. I'm in my office at PADT headquarters in Tempe, and the air conditioner is pretty dang loud. And I apologize for that. I'll filter it out, but it'll make my voice sound kind of... So it is better when I record at home in my son's unused bedroom. But let's get into the news. And first off, we'll talk about Ansys stock. And it's Friday, October 4th. I looked up the numbers at around 10 a.m. Not quite sure where they are right now. It's a little bit later in the day. But anyway, the Wall Street hasn't been doing well. They've seen some down days the last couple of days, but that hasn't happened to Ansys. Right now, the stock is sitting at, or at 10 o'clock, it was sitting at $223.66. It had peaked at $224 sometime earlier in the day. So it's actually up. Year to date, that puts Ansys at 60% growth, and the S&P 500, which has recently gone through the downturn that I was talking about, is only sitting at an 18.9% gain. So that's easy math to do. That's 20 to 60. That's 3x better. Last week, I also compared Ansys stock to other industry stocks, and I left out really the company that's the closest to Ansys as far as being focused only on simulation or mostly on simulation, and that's Altair. So I looked it up. And year to date, they are, I forgot that they were publicly traded, but they are. So year to date, they're up to 28.8%, which is a bit better than the S&P 500 at 18%, but or 19% really, but not nearly as good as Ansys at 60%. So again, outperforming the market and their competitors. The big news in the Ansys world is that they announced an increase to the breadth and depth of what you can do with elastic licenses. If you don't know what elastic licensing is, it's a way to buy time to have access to basically any Ansys tool. So we're used to kind of the model of buying or leasing a seat for a given product, say Ansys Mechanical. And I can use that one seat as much as I want for as long as I want, as long as the license is valid. With elastic licensing, you're buying access to any Ansys tool. It's just the amount of time that you actually run it. And different tools have different values, and you buy these units and use up a certain number of units per hour depending on the product. It's a great way for that 1 month to get access for that 1 month when you need an extra seat. You don't need it all year. You just need it for that 1 month. Or maybe you've got a big model and you want to run it on more cores. So you might add some HPC to your run so you can run on more cores. Or maybe you only need to use, say, Maxwell twice a year. So instead of having that seat sit there unused most of the year, you can use up your elastic licenses to get access to it. It's a real game changer. We've had customers using it both as testing and in actual day-to-day usage. And it's been a really positive experience for them. So it's a real game changer. Really recommend you check it out. They make it better and better all the time. The other piece of news that they announced is they'll be having their investor day, kind of back to the whole stock thing, on September 12th. So that's when they kind of share how the quarter went, the Q3. We've already had September 12th. They had their investor day back on September 12th. So I apologize for that. That's already come and gone. I guess it went well because the stock's up. PADT news. The only thing I have to report is that we were lucky enough to receive 2 awards here locally in Arizona. The first was on Wednesday. PADT received an award from the local biotech industry group. It's called AZ Bio, and they gave us a special award at their 25th award ceremony 2 nights ago. It was for our 25th anniversary and our contribution to the ecosystem, the biotech ecosystem in the Valley for the past 25 years. It was a real surprise. We didn't expect to win it. We didn't know they were going to give it to us. It was a real honor. And it was a special honor because for 8 years, we've been 3D printing the actual awards. They've got these cool double helixes that hold up the words that talk about what the award is. You can check that out. We'll be putting a blog post up soon. You can check that out. It's pretty cool. The other one is I was fortunate enough to be named as a top tech executive by the Phoenix Business Journal with 19 other local leaders. Actually, 18 other. There were 19 of us total, so 18 other local leaders. Math was not a requirement to win the award. What got me when I saw that I had won was how impressive the list of the other winners was. I'm really not sure how I snuck on there. There may be another Eric Miller they thought I was. I'm not sure, but I'll take it. I'm very, very honored and very pleased to have won that, and it was nice to get the recognition. So yeah, it was a big award month for us here at PADT. Can't complain about the recognition. Publication-wise, the Ansys blog, the 3 articles that I liked since the last time we did a podcast. The first one is called Fast, Accurate Transient Automotive Thermal Management Solutions. So this is really talking about what we call underhood modeling. This is where in the automotive industry, they want to know, the radiator, the engine, all the fans, all that stuff under the hood. How do you manage the heat in that environment, the airflow and the thermal transfer and all that stuff? And that used to be kind of a pain in the butt and would take months, if not quarters, to build models. And now we can do it quick. And this article talks about how and why and what's changed in meshing, what's changed in solvers to allow us to model this really complicated. If you think about what's under the hood of a car with all those hoses and things, modeling that is a pain in the butt. And then modeling it right and getting the right answer quickly is pretty impressive. The second one kind of talks about something we talked about. Ansys did a press release about elastic licensing, and then they did a blog post called What is Elastic Licensing and Why It's a Hot Topic for Engineers. And it kind of explains what it is. I kind of did a half-assed job just recently here in this podcast. This is a better explanation. Take a look at it. It's got some pictures too that kind of explain how it works. And if you're interested in elastic licensing, which everybody should be, check out that blog article. It's a pretty good one. And then the last one is from our friends over on the optical side of simulation. It's called Optimize Optical Design Using Real-Time Simulation. Lights and lenses is what it's really looking at. It's not designing the optics in a device. It's once I have a device, maybe it's a light, maybe it's a headlight, maybe it's a mirror. I don't know. It's something that in the scale of a room or a vehicle, modeling how that looks optically, and it's in real time, so you can move things around and see how it affects what it looks like to the human eye in a virtual environment. And I just like the topic because it looks cool, and it sounds very useful if you're in the optics space, the lighting space, or designing lighting. Pretty neat stuff. We had a blog article that went out. Seema published an article. She's one of our HFSS support and pre-sales engineers, and it's called Temperature-Dependent Material Definitions in Ansys HFSS. So this is high-frequency electromagnetics and how to define your temperature-dependent materials in that package. Very useful article for those of you using HFSS, kind of based on a lot of questions she's been answering for tech support and helping customers get up to speed on the product. Upcoming event-wise, we've got a webinar to talk about what Doug and I just talked about, topological optimization and simulation for additive manufacturing in Ansys 2019 R3. So this is where we actually look at the pictures and show some animations, I think, in this particular one, and get a real good look for what we were talking about in the podcast. So you have time, sign up for that. It's the 9th, Wednesday the 9th, from 11 to 12 Pacific time. And as always, with all of our webinars, they're on brighttalk.com, and you can search for PADT to find it. And you don't have to listen to it live. You can sign up at any point and download the recording if you miss it. Other PADT events on the 24th will be at the 2019 Arizona Governor's Celebration of Innovation Awards and Tech Showcase. This is our big annual event for the tech community in Arizona, a gala, one would call it. Some people even wear tuxedos. I will not be wearing a tuxedo, but I might be wearing a suit. So it is unusually formal for me. That's from 4 to 8:30 at the convention center downtown. If you've never been, if you're local here in Arizona, you've never been, it's a fun event. And there's a lot of companies, a lot of the local tech companies show up for that. And then the large tech council event in Tucson is the 2019 Southern Arizona Tech and Business Expo. And that's going to be on the 30th from noon to 6. And that's always a fun event. And we get to spend time with our Tucson customers at that. And we're looking forward to being there. And that's it. Thank you very much. Our job with this podcast is getting a little bit more difficult because there's so much to talk about. So keeping it concise and picking the important things is what we're focused on. But I think it's a good thing that we've got so much to talk about. Don't forget to subscribe at www.padtinc.com/opt-in for our emails and newsletters. Spread the word. We'd love to have more listeners to the podcast. And never hesitate to reach out and send us an email or give us a call or talk to us on social media, whatever works for you. Thanks. Thank you for joining us for the All Things Ansys podcast, episode number 48. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employer. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.